So sometimes we're trying to find a common denominator when we're doing some work, and so we need, if we have something like, say, 3 over 14 plus 5 over 20, we can't add these together right now because we need 14 and 20 to become the same number. So what I'd like to do is this. Sometimes people like to say, well, if you find all the common multiples, it'd be 14, 28, 42, 56, 70, and you're going to see it's going to go on for a long time. And then, as of right now, well, just start with 20, 40, 60, 80, 100. You're going to see that there's a problem because we're going to have to go on and on and on forever. So I don't necessarily like doing common multiples, but you can do them if you like. The other thing you can do is I can say, all right, well, what are the factors of 14? I have a 2, I have a 7. What are the factors of 20? And by factors, I mean the prime factors. So 20 is really the same as 2 times 2 times 5. 2 times 2 is 4. 4 times 5 is 20. 2 times 7 is 14. So right now, 14 and 20 both have 2 in common, so I can get rid of this. But 14 has a 7, and 20 doesn't. And 20 has this extra 2 and 5, and the 14 doesn't. So if I multiply by these, and now you're going to have to put these 2's back in. You take a look now, these should all be the same. 2 times 7 times 2 times 5 is the same as 2 times 2 times 5 times 7, which is 2 times 2 is 4, times 7 is 28. Well, 2 times 2 is 4, times 5 is 20, times 7 is 140. And this is 140. So what did I need to add to the 14? I had to multiply an extra 10. And what did I need to multiply to the 20? I had to multiply an extra 7. And so that gives me a common denominator of 140. So this would be 10 over 10, and this would be 7 over 7, and I get 30 over 140 plus 35 over 140. Sorry, I know that's really messy and you can't read it. You'll get 30 over 140 plus 35 over 140, and now you can add them. You get 65 over 140, and you can simplify. If I have a squared b c cubed, and I had a b squared c cubed, it's kind of the same. What does this one need that that one has? And so here I have a times b times c times c times c. Here I have a times b times b times c times c times c. This one has an a, and this one has an a, so that's fine. But this one has another a, so I'm going to have to multiply this by an a. This has 2 b's, and this only has 1, so I need to multiply by a b. And then those all have c's, so we're all set. When I do that, I'm going to get a common denominator of a times a, which is a squared, b times b, which is b squared, and c cubed. Now, you'd have to multiply whatever this numerator was by b, and this numerator by a. Here, I'm going to take a look. What if I had factors? And so I'm going to make this into an actual problem. X squared minus x minus 12 plus 4 over x squared minus plus 2x minus 24. Well, let's take a look. I can factor this, and if I do, I get 4 and 3. It's going to be a negative and a positive. If I factor this, I'm going to get 4 and 6, and it's going to be positive and negative. Now take a look. These two are exactly the same, except, no, that's not true. They're not exactly the same. These are similar because this has an x minus 4 and this has an x minus 4, which means this side would need an x plus 3. Would need an x plus 3. over x plus 3. And this side would need an x plus 6. No, I shouldn't really write that. So when we did it, you'd have to multiply this by x plus 6. I'm going to have to make some room here. And you'll get 3 times x plus 6 over x plus 3 times x minus 4 times x plus 6 plus 4 times x plus 3 over x plus 3 times x minus 4 times x plus 6. Ooh, ran out of room. Alright, maybe not the best example I've ever done, but that's alright. I think you get the point. The last one is what if I had opposite factors? So if I had x squared minus 16, that's going to become x plus 4 and x minus 4. And 12 minus 3x, I can factor out of, that's not true, I can factor out of 3. And when I do that, I get 4 minus x. Well, that's no good because this side needs a 3, so I would have to multiply by a 3. And this is no good because it's 4 minus x. But remember, if I multiply this by -1, that would become a -3, and that would become 4 plus x, or x plus 4, which would mean that this would also have to become negative. So I'd have to multiply by a -3, and then I also have to multiply the side by an x minus 4. It's a little bit of a tricky concept. If you watch this before you watch the next video, which is going to be on adding and subtracting numbers of rational expressions without common denominators, this will make a lot more sense. You might actually want to watch that video first and then watch this video second. But it doesn't matter. The order doesn't matter.